Hi guys, welcome back to my YouTube channel. So in today's video, we're going to talk about JavaScript numbers. So we're going to talk about what are JavaScript numbers and how to use them. So JavaScript numbers play a crucial role in JavaScript programming, helping us store digits and perform mathematical operations. So as you all know, numbers are integers. You can do mathematical calculations, addition, subtraction, multiplication, division. And now let's move on to the table of contents. So we're going to start with the introduction. What are numbers in JavaScript? Next, we're going to talk about how to declare numbers. And then next, we'll talk about number precision, floating point precision, addition and subtraction of numbers, and then a caution about adding numbers and strings. Then you're going to talk about not a number, infinity and negative infinity. Then number 9, we're going to talk about converting numbers to strings. Then numbers as objects, number methods, number properties, and finally the conclusion. So let's start with an introduction. So a number in JavaScript is a data type representing digits and floating point numbers. So i.e. decimals. And then unlike other programming languages that define multiple numeric types, e.g. int, float, short, long, maybe like C, JavaScript uses one number type for all numbers. And then all these numbers are stored inside a 64-bit double precision floating point values as defined by the IEEE 754 standard. So this means that integers and floating point numbers are essentially the same under the hood in JavaScript. So let me pop up my VS Code and then we can start. So we have said that JavaScript numbers can hold integers, e.g. 3, 4, 5, like that. And also they can hold decimals, 3.14. And all these are held inside the numbers data type. Okay. So JavaScript doesn't have specific number types for integers, for decimals, for float, long float. Like in C, you have long float, we have float, we have int, all those. But in JavaScript, it's just one data type that holds all. So if you go back, you can see. So let me just copy this and show you. So if we have something like this, we have an integer assigned to variable A, and then a floating point assigned to variable B. And if we console log the type of this variable, so using this method, so let me hover over this. Using this method, we can get the type of a variable. So we talked previously about JavaScript variables. So these are variables which store values of integers and floating points as numbers. So as we have said, the syntax of writing a number is that you don't have to enclose it with anything. You just type out the number. Even if it's a floating point, you just type it out. So if I save this and run index node index.js, we can see both of these are of type number. So let's move on in declaring numbers. To declare a number variable, you assign a digit number without quotes or anything, just plain, to the variable, or you can use it direct. So if it's a decimal, you type it out as it is. So let's use the same. So we can have let age equals to 20, and then let temperature is equals to 37.5. So this is a decimal. You just type it out. You don't add anything. Then this is a number or an integer. We can say integer. Right. So just type them as they are. There is no quotations, there is nothing. You don't add, it's just plain numbers. The next thing is number precision. So precision means how exact a value is. So precision is the number of significant digits a number can represent. So let me copy this and show you. So if you have pi, I can do, yeah. So if you have pi is equals to 3.1423 and it has more digits, we say this one has a high precision compared to 3.14. All right. So the higher the number of digits, the higher the precision, and vice versa. So because all numbers are floating point numbers, JavaScript numbers have a precision of around 15 to 17 decimal digits. So this one has 15 digits and it's accurate, but this one has 16 digits, and then when rounded it goes back to the nearest, like it truncates. So yeah, that's it. That's a bit about precision. Then we go back, we go to floating point precision. One of the classic examples of floating point issues is, so floating point has issues. So let me show you. This is something we need to take note of. So if we do console log 0.1 plus 0.2, so before we continue with this, you need to understand that you can do operations on numbers. So we can do addition using the plus sign, subtraction using the negative, and then you can do division using the forward slash or the slash, and then we can do multiplication using the asterisk. We can do the modulus using the percentage. So these are operations that we can, these are mathematical operations. So here we intend, our intent is to get 0.3. All right, let's see what we get. We get something, we get something that is not what we expected. And this is one of the issues that JavaScript has. So we do have 0.1 plus 0.3, but this one is not giving us an exact 0.1 plus 0.2, not giving us an exact 0.3. So why is this? So this happens because like 0.1, numbers like 0.1 and 0.2 cannot be represented precisely in binary, leading to tiny rounding errors. So we encounter rounding errors whenever we work with such tiny numbers. So take note of that. This is very dangerous because in case you are working with a financial system and you do something of that sort, you are going to get errors, and someone might be withdrawing more money. So if you are moving a lot of volume and then you have such rounding issues during rounding, then you encounter errors that are very critical and can lead to financial loss. We'll talk about this and how to mitigate this later on. So you can do operations on numbers. So also we do have the same caution here whenever doing subtraction. So you have the addition, the subtraction, all this leads to rounding errors. All right, so we can do basic arithmetics. Let me just show you. We can do basic arithmetics. So we can do console.log 1 plus 1. We can do console.log 1 minus 1. So this is subtraction. We can do console.log. We can do maybe 4 divided by 2. So this one is division. This one is division. Can do subtraction. Can do addition. And then let me add here 1 plus 1 equals. So 1 plus 1 equals, and then this one we can do subtraction. 1 minus 1 equals, and then we can do division. 4 divided by 2 is equals to, like that. And then the rest we need to work with console.log and multiplication. So we can say 3 multiplication 3 times 3, use an asterisk, and then we say equals. Then we do 3 times 3. And then finally, we can talk about modulus. So modulus is the remainder, so we can do modulus of 5 modulus 3, and then we do equals, then you do 5 modulus 3. So this one is modulus, then this one is multiplication. So we do here, come here and do our classic console.log. The execution of that file, we can see addition of 1 plus 1 is 2, subtraction is 0, division of 4 by 2 is 2, multiplication of 3 by 3 is 9, and the remainder of 5 divided by 3 is 2. So that proves that you can do operations, basic operations with JavaScript. So the next thing we need to check is the same issue we had, whereby if you console log 0.3 divided by, is it divided or minus? Do we use divided or minus? So minus 0.2. So we expect to get 0.1. So let's see what we get. So if you do run this, we get something weird because of rounding issues. The 16 floating point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17. So we are going up to 17 digits, as I said here. So a 15 digit is accurate, but a 16 digit is rounded. All right. And then whenever it's rounded, we get into issues with rounding because, so let's see, we can do, so 0.3, no, 0.3 minus 0.4. Yeah, you can see we have the same issues with rounding, and we get into errors that we'll talk about later on. Right, so let's move on. We'll talk about the floating point precision, which is causing issues. Then one of the classic examples of the floating point issues, we said the 0.3. So it has tiny rounding errors because of the floating point issue. So these tiny errors can accumulate and affect calculations in sensitive applications like financial software, which would be very costly. So why does this happen? So let's talk about why is this issue happening in JavaScript. So decimal numbers like 0.1 and 0.3, 0.2 cannot be represented precisely in binary floating point. So they cannot be represented precisely in binary floating point. So 0.3 minus 0.2 ends up to be something like 0. All these instead of exactly 0.1. So how can we solve for this issue? This is a non-issue. So the first thing we could do is use rounding. So we can round off to a fixed number of decimal places, and commonly used decimal places is 2. All right. So we can round off this into You can see the rounding issue is coming because let me show you. So 0.1, let's do 0.1 plus. So in this, we expect to get 0.3. But due to the floating point precision, we get this. So what we could do is to round this off to 2 decimal places. So let's see what we can get. So we can say, we can do like this because we want to work with this expression. Or maybe we can write it somewhere and call it res. And then we can use our res. So we can say let res is equals to 0.1 plus 0.2. So we have said the first method we can use to remove this issue is to round off to fixed decimal places. So you might find, like in most financial operations, if you had $200, let's say you have 200, you normally see it like that. It's rounded off to prevent these tiny errors, which would be very costly. So we can use the same technique whereby, as I had talked about classes in strings, we'll talk about this in this tutorial. But to know is that all these numbers inherit from a base class called number, which has functions inside the class which are called methods. And these methods are available to all the members that inherit from that class. So one of the methods we have in numbers is toFixed, and we can use it for fixing to 2 decimal places. And then let's see what we get. We get 0.3, exactly what we wanted. So that's the first way we can do it, because this one removes all the errors and rounds off. So in case we had 0.23, 0.258, so what will we get? We're going to get 0.36, something of that sort. Why? Because it will round off this to the nearest 2 decimal places, the same classic mathematics, and then that will remove our errors. So in our issue that we had, without fixing it without rounding it off, we had all this. But if we fixed it to 2 decimal places, then you can see now it will round off, and because this one is not greater than 5, then that won't work. And won't work, but it is not greater than 5, you'll still get 0.3, which is our desired answer. The next thing is to use integer math and avoid floats. So the issue is with floats, so we can use integer math to prevent this. So how can we use integer math? So we can write all our expressions in the next domination. So in case you are using dollars, instead of using 0.1, let's say this one is dollars, we can convert to the next domination, which is cents, and we can multiply with 100. So we can do num1 times num2. Then let's create num1 and num2. Let num1 equals 0.1. Let num2 equals 0.2. All right. So what we are saying, this one is in dollars. We can change it to the next domination, and then we can change this to cents. Then instead of working with dollars, we work with cents. And then the result is in cents. And then let me first show you what we get. We get 200. So what we did a multiplication. We can do addition. You can see. So we get 30 cents, and then finally we can divide with 100 to get back our 0.3. Okay, so this one is the method of running away from floats and working with integers. So the next one is to use a math library, for example, decimal.js, bignumber.js. So let's work with decimal.js and see what it does. So you can create decimal numbers and then you can do operation with the decimal. You can do, it has so many useful functions we can add. So we can do decimal.add x and y, and this one will prevent us from, so this is a library that has been written by the community to solve for those errors. So you can read more about this, and then you could use this technically to prevent those issues, and then there won't be an issue. So the next thing we need to caution about is JavaScript adding numbers and strings. Okay, so there's an issue with JavaScript. So JavaScript does something called type coercion, and so this type coercion means it converts. So let me just show you. So whenever you add a number to a string, okay, so we are adding 5 to a string of 5, JavaScript will convert. Let me just show you practically. So when you do this, JavaScript will convert the number into a string and then concatenate it to the string, and we get the number 55. Okay, so this is on addition. This is what we call type coercion. So JavaScript will convert this into a string, and we said strings concatenation. So str1 plus str2 gives us str1, str2. Okay, this is how you add strings. So let me just show you. We can say console.log str1 plus str2. You can see what we get. So when JavaScript does the type coercion, it converts this into a string and adds it to the other string, which ends up to be string concatenation. And what does JavaScript do on numbers subtraction? Instead of now converting this one into a string, because we cannot subtract strings, there's no such a way to subtract a string to a string. It converts now the string into a number and then does the calculation. So that's why we end up with 3, because it converts 2 into a number and then subtract it. So you have to be very careful wherever you're working with JavaScript numbers and strings. Don't mistakenly add a string to a number and subtract a string from a number. Okay. Always be mindful of these types when performing arithmetic. Prefer using a number construct a function. Now this number method converts a number string into a number. All right. So the next thing we need to talk about is the not a number. So not a number is an exceptional numeric value that represents not a number, and this one mostly occurs when you do numeric operations that are invalid. So like 0 divided by 0. So if you do console log 0 divided by 0, we get not a number. All right. Yeah, so this one mainly occurs when you try to do operations that are invalid. So the next thing you need to understand is some important facts, is that the not a number is of type number, and not a number is not equal to another not a number. Okay, so if you need to check whether it's not a number, whatever is the result, you can use the is none function. So I talked about functions. So if you say let result is equals to 0 divided by 0, so in case we wanted to check whether this is not a number, the value of the result, we could do console.log res.is number.is none res. Okay, so this is the syntax you could use to check whether something is not a number. All right, and as I said, every number inherits from the number constructor, which has methods. And as I said previously in my string tutorial, is that a method is a function inside a class. And this is exactly what happens. So this res number is converted, has access to the methods in the base class, which is a number class. We'll talk about that later. And then the next thing you need to understand is the infinity and negative infinity. So JavaScript uses infinity and negative infinity to represent values that exceed the numeric limit. So we do have the 1 divided by 0 is infinity, and then negative 1 divided by 0 is negative infinity. And also you can compare positive infinity is similar to infinity. All right, this is not commonly used, so we are going to continue. Then we can convert numbers to strings using a couple of ways. So let me just copy this and then we can go through it real quick. Is that we have our number variable here. We can convert it to a string by doing number.toString. So the number is an instance of the number class. The number class I'm talking about is this. So it's an instance of it, and then the number class has methods, which are functions inside the class. I'll show you later on what I was talking about, but now this number has access to some special functions that help us to do some specific tasks, like the number.toString, we get a string representation. And then we can also use the string class constructor to convert a number to a string. And then we can add a number to an empty string so that we can get a string. You saw what happened when we tried to add .log 55 plus 55. Due to type coercion, we get something like 55 because, as I said, in type coercion, whenever you add a number to a string, the number is changed back to a string, and then you concatenate the string. So what if we concatenate an empty string to a number, we get the string representation of the number. So if we do run this, we get the desired, but all these are strings. All right, so you can also format numbers. So the first formatter we talked about is the toFixed. It affixes. So the toFixed 2 talks about decimal places. So we do have 1, 2. I hope you can see. And then the toPrecision. Now this one is exact numbers. So toPrecision 4 means we need 4 numbers, whether there's a decimal or not. So we start from here, 1, 2, 3, 4. Right, so let's continue. Number as objects. So here's where I was talking about inheritance. So you can also create a number using the number constructor. So I can copy this and then come here. So we can create a number using the number constructor. All right. So this way of creating, let my number is equals to 456. This one is called the primitive way. Then this one is using the object constructor. So the primitive also inherits from the number. Okay. So it's an you can see it's also an object that represents any kind of number, but still this has access to whatever this number initialized using the number constructor has. So if we console log the type of that number, we can see that it's an object because now this one is using explicit number constructor. However, this is discouraged. Most of the time you should use the primitive numbers, which are more efficient to work with. So this one is the primitive number, which doesn't use the new constructor. So, and also the comparison behaves differently. So if you have a number initialized using the number constructor, this one is an object, and then this one is a primitive and it's a number. This one is an object, this one is a number. Because, so if you try to compare them, we do get that the double equal sign compares the value, and then this one compares the type. So this one is of type object and this one is of type number. Best practice, always use primitive numbers unless there is a specific need, of which it's rarely there is. So let's explain about what happens under the hood. So numbers inherit from the number object. Even though it's a primitive number, aren't technically objects, JavaScript wraps them temporarily when you access methods or properties. So this is possible because all numbers inherit from the built-in number object, which acts as their prototype. So a method is a function attached to an object or a class. A property is a variable attached to an object or a class. I'll talk about this again. So class animal, we call the constructor, receives in the name. Then initialize and then move console move. So if you want to create an animal, this dot name plus is moving. All right, so if you want to create, so we said a class is a blueprint. A blueprint is like an architecture design for not an architecture design. Let's assume you have t-shirts. Instead of recreating t-shirts, you can create a constructor that defines the basic things that a t-shirts need, and then all the other t-shirts created inherit from the base t-shirt. So what does a constructor do? A constructor initializes, like it sets the ground before starting anything. Let's set the ground so that we can know who is this. Maybe you want to identify who, so that below the class, wherever there is a method that is accessing the name, we need to know who is this. So in case we want to create an animal, let's call it let first animal. Let me use dog is equals to new animal and then pass it dog. Right? And then we can call, because we are already console logging, we can call dog dot move. Let's see what we get. So if you go back here and do this, we can see dog is moving. Why? Because we use the class, the animal class, because all animals have almost, let's say we are talking about mammals. Mammals have characteristics. They are warm-blooded, all those. So that's why you create a class to represent all the mammals. And then from the class, you can create a new mammal. Maybe you can create a dog, you can create a sheep, a cow, all those. And then a constructor helps us inject values that we might need. So maybe you wanted to add an age. You can do that. You can add age, all those, and then remember them to come and initialize them in the class. So this is not a class course, but I wanted you to understand. So let me show you something similar. Let my favorite number is equals to new number. And then it's, maybe my favorite number is 45. And then we can do my favorite number dot to string or dot to fixed. I wanted fixed to 2 decimal places. And then console. All right, so do you see the similarity between these 4 lines? So these exact things that is happening. So whenever you create a number variable, whether it's primitive or it's an object, it accesses the methods that are from the base class. Okay, so all numbers inherit from the base class number. All animals inherits from the base class animal, and then we can call methods inside the base class and use them the same way you called my favorite number.toFixed. This is the function that is created inside the class, and it's accessible to all the members using the class. So this is a brief introduction about classes. If you'd like me to create a tutorial about classes, make sure you leave it in the comments section. So I hope you can see the relationship, and then why do we have to access all this. So if we go back, we said a method is a function attached to an object or a class. A property is a variable attached to an object or a class. And then so primitive numbers like 1, 2, 3 have access to all the methods and properties of class number. I hope you understand. And then now you can access functions that are defined inside the class, which have a name called, and they are called methods. And then you can do something with them. So you can do the toFixed, and then you pass that, the constructor. So this is what happens under the hood. The prototype chain gives numbers access to practical methods like the toFixed, to exponential, to precision, to string, and more. Even though you write let x equals to 42 and then you do fixed. So what does JavaScript do behind the scenes? So it temporarily converts x to a number, calls toFixed, calls the method you are calling, and then discards the object wrapper. So we could go deep into prototype chains, but now the tutorial might get too long. So we are going to move forward. So the next thing we have is number methods. We have the toFixed, which you already seen. It returns a string of the number returned with the provided decimal points. toPrecision, I already told you. It returns a string of the number returned to a specified length. Then to exponential, returns a string containing a number represented in exponential notation. And then to string, we already talked about this. And then we have something called the number properties. And as I said, a property is a variable defined inside an object or a class. So we have very many variables that are predefined, the minimum. All these are self-explanatory. We can access the maximum value. So this one is the largest possible number. All these, you can go through them. And then in a conclusion, we have talked about JavaScript numbers. Now it's up to you to do practice so that you can be able to work with the numbers. And then finally, as an exercise, you can read more about the BigInt numeric type and write down in the comments so that I can see what you learned. So also you can follow for more content. And that's it from me, guys. Happy coding, and make sure you subscribe to the YouTube channel and share with your friends. Click on the bell notification. Thank you.